everyone. In this class, we will shed light on the topic types of overlapping and nature of covalent bond. We can classify covalent bond into two types based on the type of overlapping into sigma bond and pi bond. So first we'll discuss sigma bond. So it is the bond which is formed by end-to-end overlap of bonding orbitals. Okay, so what is end-to-end overlap? Here we can see in this picture that one end of the s orbital has overlapped with another end of the s orbital. Okay, so when this type of overlap takes place, it is called end-to-end overlap, and this overlap always occurs along the internuclear axis. So what is internuclear axis? We can see from this picture that it is an imaginary line drawn between two nuclei. Okay, so this is internuclear axis. Fine. And all the sigma bonds are formed along the internuclear axis. This type of end-to-end overlap is also called head-on overlap or axial overlap. Axial because it is along the internuclear axis. Okay. Now, sigma bonds can be formed by any one of the three combinations, which are SS overlapping, SP overlapping, and PP overlapping. So first one is SS overlapping. So it is formed when there is overlap of two half-filled s orbitals. Okay. So this is relevant from the picture. Now, second is SP overlapping. Here, half-filled s orbital overlaps with half-filled p orbital, as we can see. Okay, in all the cases, the bonding orbitals overlap along the internuclear axis. So third one is pp overlapping. So in this type, half-filled p orbital of one atom overlaps with the half-filled p orbital of another atom. Okay, so this is what pp overlapping is. So all these are sigma bonds. Okay, so next is pi bond. So pi bonds are formed as a result of sideways overlap. Sigma bonds are formed as a result of end-to-end or head-on overlap. But pi bonds are formed as a result of sideways overlap. So what is sideways overlap? You can compare these two pictures and easily know what is the difference between a sigma bond and a pi bond. See, here the sideways overlap of p orbitals has taken place. Okay. Now, in the formation of this pi bond, atomic orbitals overlap in such a way that their axes remain parallel to each other. So what is that? This is a p orbital and this is a p orbital, and their axes are these two lines, right? So we can see that these two axes are parallel, and these two axes are perpendicular to the internuclear axis. Okay. Now, the pi bond that has formed now consists of two saucer-shaped negatively charged clouds. We can see here, this is negatively charged clouds which is above and below the plane of participating atoms. But in case of sigma bond, not pi bond, in case of sigma bond, the negatively charged cloud is symmetrical about the internuclear axis, but in case of pi bond it is present above and below the plane. Okay, so with this we conclude our topic, which is types of overlapping and nature of covalent bond. For more videos like this, stay tuned. Thank you.